Okay, I guess I'm in this up. So we'll go ahead and get started. All right, I am Sam Edwards. I work at Capital One, and I'm going to talk to you about mobile payments on Android today using host card emulation. So this link up top is a GitHub project that you can go and check out, and there's a video demo in the middle of me actually using this project at Dwayne Reed and a few other places. So this project will work. I'm going to talk through how you can actually get your card into the project, but I'll show you how you can do that. So anyway, this is a real functioning app. We're going to talk through how it works and how host card emulation works on Android. All right, so a prerequisite for communicating with the payment terminal is NFC, so I'm going to have a video explain it.
NFC is a technology where it allows phones and other devices to communicate with each other via this very short radio signal.
You will be able to connect to your TV, to your tablet, to any other electronic device just with a touch. You have to get very close. You have to touch. Touch.
Tapping.
Touch.
Touch it. Tap. Tap in.
Just with a touch.
You don't have a business card? Boop.
Touch my phone to get something. Done.
Okay, I figured that was quicker than me just going through it. But NFC has three primary uses on Android. One is the static NFC tags, where you would just tap your phone against it. I'm going to show that real quick. So the tag looks something like this here. And what you can do is you can take your Android phone and you just place a tag behind it. And in this case, I have my personal website URL on there. So it launched up HANDSTAND SAM. And now another feature, which is the next one on there, is Android Beam, which is an API available that you can basically send an intent to another phone. So if I have this other phone here, I hold them against each other. It says touch to beam. I'm going to go ahead and do that. And then this magically gets an intent to open up a URL. So that's pretty cool. And then the last use was for payments. So that's what we're going to talk about. But NFC is a subset of RFID that allows you to talk to another object if it's like within like 10 centimeters or less. So it's very close range, as you're saying, just a touch. All right, so the history of NFC payments on Android without boring anybody was the first NFC APIs were available in December 2010 with Android 2.3. However, at this point in time, they were pretty much restricted, and only the hardware manufacturers had secure elements in there. So payments could only be done with a certain manufacturer and a carrier. So if like Verizon had a Samsung phone, then they would have to have a specific payment app that worked with both of those and had the internal APIs. Where then in October 2013 with KitKat, we have HCE, which is what we're going to be going into, which allows any Android phone that has KitKat or higher with an NFC chip to be able to talk to a payment terminal. So this opens up a wide array of opportunities because we're not locked into having to have this specific secured element access. Just a quick diagram. Here at the bottom, you'll see the NFC reader has a red arrow going into the secure element. This is typically how it worked, where when you wanted to send your payment information, it would have to talk through the secure element and then send that information back. Where now with host card emulation, the NFC reader can talk directly to your application. So you have a Java application that's going to send the commands back, and we'll go through that. So in its basic form, host card emulation is just a way to simulate a smart card with Android 4.4 and NFC. All right, and just a quick stat, I looked this up on developer.android.com, and it looks like 57% of phones are on KitKat or higher. I feel like it's a lot more than that. Some of our apps have looked at the stats, and it's more like 80% or higher. But this is Google as of August 3rd this year. So that shows you that any of these phones that have KitKat or higher that have an NFC chip, you can make payments on with host card emulation. Sorry. Oh, like the volume? Oh, sorry. Oh, is that better there? Or?
Yeah, it was just like overpowering the other room.
Oh, sorry. Okay. No, that's good. All right, so I'll go here. Okay, great. Sorry, guys. All right. Now, obviously, we're all here because Android's better than iOS, but specifically, it's better than iOS because we have open APIs for both NFC, which is like the tags, and with Android Beam, but also we have HCE APIs, which we're going to talk about. iOS, in order to do payments, you can only do it with Apple Pay, which means they have proprietary APIs that nobody can access, and you can't innovate with any cool new things like, I don't know, yeah, you can't do anything cool. So on Android, you have HCE, and then you also have the ability to communicate with the payment terminal with a secure element, but that's locked down. And then on iOS, it's just the secure element-based version. So opportunity notch, right? So we have all these Android devices out there that have KitKat or higher, that have NFC. So any of those we can make talk with payment terminals to actually make a payment. And why this opportunity is getting even bigger is in October, which is like a month from right now, you guys are probably already getting these cards with the little chips on them in the mail. And the reason is because there is this shift in liability. So you're going to be seeing these MAGSTRIPE data terminals, which I'll show you those in a minute, but one of these things are going to be kind of switching over to what you see in Europe, which is the chip and pin, chip and SIG, and so forth. And that uses these EMV chips. So the reason why this is a big thing, and you're getting the cards in the mail, and you're going to see a lot of payment terminals changing, is because the amount of fraud that can happen. Because right now, when you go ahead and swipe your card, that data can be replayed and used over and over again. Or if you use one of these EMV chips, it generates a cryptogram, and then that's going ahead and send along, and it's only valid for one-time use. So basically, if somebody hacked Target or Home Depot again, it would only be valid for that one payment, so they can't use your card credentials again. So anyway, in this case, in the case that is now with the new mandate, I just have an example of Acme Incorporated and the bank that gave you the card. Whichever one of those does not support EMV payments as of October, then they're going to get charged for the bill if there's fraud happening. So Acme Incorporated, so you're going there and buying some groceries, and if they don't have an EMV terminal and they get hacked, they're liable. Opposite, if your credit card doesn't have an EMV card or chip in it, then they're going to be liable. So sweet and simple is more terminals, more mobile payments. This is the graph that everybody wants to see, but this is October of last year's, or September that came out. It was basically just showing a huge growth projection based on that mandate that came out, plus the availability on all of these phones that we have that can make payments, along with other devices as well. Just a quick overview of how the payment landscape looks in the United States right now. Kind of the four main big players, and one of them Google Wallet and Apple Pay, or Android Pay are kind of the same thing. But we'll talk about that. So Apple Pay, if you talk about mobile payments to anybody, like even when I talk about this speech, I'm like, oh yeah, it's like Apple Pay for Android. They're like, Android Pay? I'm like, no. So anyway, like whenever you talk about payments, contactless payments, you're always talking about Apple Pay essentially, which is a little annoying. But in this case, they control the user experience. It's the only way to do a contactless payment with an iPhone, and they use a secure element-based stuff. So that means because they are the manufacturer and they are also the software provider on there for the operating system and everything, they have control of that entire ecosystem. So they can do it. Where in the past, like if you had Verizon and you had Samsung, they'd have partnerships and so forth. So with Apple Pay, it's working pretty well, which is nice, and meaning that like, we're going to be using those terminals that are out there. So Samsung and Loop Pay. So you might have not heard of Loop Pay, but Samsung Pay is coming out. It's actually in beta right now as of Tuesday. I have not got to try it, and it comes out September 28th publicly. So it supports contactless terminals as well with a secure element. So that's not using HCE. And then it also supports MAGSTRIPE terminals with a really cool technology that Loop Pay created. So I'm going to show you real quick what Loop Pay is, the technology that they acquired. And so that's actually built into the Samsung Galaxy S6, the Edge, and then everything going forward with Samsung. So this is Loop Pay.
Technology that already works just about every place you go today. Just place your Loop Pay device right against where you normally swipe a card, press a button, and bam, you've made a payment.
Wow. That's totally killer. That's awesome.
Thank you. So you're wondering how we made all of this happen. You see, when you swipe a card, the card reader receives a magnetic signal from the MAGSTRIPE and sends the card data on for approval. Loop Pay invented a breakthrough technology that transmits the same magnetic signal wirelessly to merchants' existing MAGSTRIPE-only or EMV chip card-based terminals, making it 40 times more accepted today than Apple Pay.
I'm very impressed that it works. Yeah. Especially, I mean, we don't always have the most updated system.
So as you can see here, this is actually using all the current MAGSTRIPE terminals that are currently out there, which is really cool because it's going to allow Samsung Pay to actually go ahead and make contactless payments as you see normally, but then also work on any terminal. So I'm super excited to see this like in real use, but yeah, I haven't used it myself. It looks kind of too awesome to be true. So actually, in that whole argument now with manufacturers and carriers, Verizon has not yet approved them to have Samsung Pay on any Verizon devices. So they kind of hold that power as a cell phone carrier to block that, because they have their specific versions of Android they put on their phones, like with all their bloatware and so forth. Okay, so now actual HCE implementations that you guys are seeing. So Google Wallet and then Android Pay both use HCE. And so those are available on any Android phone that you have that has NFC and 4.4 or higher. Google Wallet is a little bit different, and they're getting rid of that for a few reasons. Well, not rid of Google Wallet, but as far as the payment side of it. With Google Wallet, you essentially get a virtual MasterCard. And so on your device, whenever you make a payment with Google Wallet, it's using this one MasterCard. And then when you do make the payment, you have a setting in there that says, okay, I have an Amex, I have a Discover, I have a Visa, and I want it to charge to that card. So it taps with the MasterCard, but then goes and charges your account that you have on file. So it's kind of nice in that respect because any card you have in your wallet can be used as a contactless payment. But I think that's caused a lot of complications. So they're moving to Android Pay, which is very similar to the way that Apple Pay works as far as the ecosystem. However, it is using HCE, so it can work on all devices and not the secure element-based system. With Android Pay, like you'll notice maybe all the banks in the beginning won't have support for it, and that's because it requires issuer integration. So on their servers and so forth, they're going to have to like basically implement the systems that Android Pay needs in order to like get the correct payment credentials and so forth. So those partnerships have to be there. In this case, and I'm going to talk about tokenization a little bit later on and how that works with these, but in Android Pay, you're getting a tokenized version of the original card, and it's going to work for both contactless as well as in-app payments. I saw Priceline downstairs. I've used their in-app payments with Google Wallet. Works really well, so it'll be similar with Android Pay. I don't know their plan specifically, but that's been my experience. So, yeah, so the app I talked about in the beginning is called HANDSTAND Pay. The reason it's called that is because my online handle is HANDSTAND Sam. I have a bunch of handstand photos all over the world. Anyway, so what I want to do is show you a video of this working out in the real world, and this is the exact code that is available here. I actually have about $4 left on the card that I'm going to be showing you guys, so if you download the app and use it, you get $4. Yeah, so let's see it in action, and here it is. It's a pretty epic moment when it actually works. That's good.
Three, two, one.
Cool. Did I go through? Or? Okay.
It's Apple?
Yeah.
Yeah, you have to.
Okay. Yeah, there it is. Awesome.
Oh. Do you want yours?
Sure, thanks. Appreciate it. You too. This is yesterday.
Anything else?
No, just pay this.
Okay.
All right, awesome. Oh, sorry, I didn't donate with my prepaid card. I'm a bad person. I don't have a pen, so just...
Credit?
It's credit, yeah, there it is.
Okay, well, I've been looking for some purposes of the tickets get in line.
Mile High Club. Thank you. It's a little creepy the way I filmed this, but I don't know how else to do it. I know, okay. Take out the way. Okay, gotcha. Okay, sure.
Oh, here we go. It might be me, actually. I had an airplane mode. So let's try again.
Press the button again, so it's flashing.
Oh, there it goes. Got it. Okay. Yeah, it was an airplane mode, so I didn't know.
So you just swipe the back.
It touched somewhere in there. So did that go through?
That is,
Sweet.
I like it.
All right, so as you can see, there's a few trials and tribulations, but the app works, so yay. So some lessons learned from that video and some other experiences I've had is, as I said at the beginning, everybody calls it Apple Pay, just how it works. Unfortunately, when you go to a vending machine or you go somewhere like Dwayne Reed and you don't have to really interact too much, you can just tap, but any questions, it's Apple Pay. Also, single tap versus double tap, it's kind of an annoying thing, but you saw a Panera, I did it once, it kind of went off and didn't go through. But that's because you have to send multiple commands over the terminal, so it's not just one payment, and we'll talk about those commands. But in that case, it didn't send all of them, so the payment information didn't go all the way through. And that just kind of happens sometimes, it times out. Airplane mode, I didn't know NFC was disabled during that. I knew Wi-Fi and cellular was, but I didn't know something within 5 centimeters is going to cause a plane to go down. So didn't know that, but we figured it out. And then also, yeah, employees are not trained on contactless. These people didn't know, but then everybody else, like, oh yeah, Apple Pay, what's that? So. All right, so now let's actually get into the code of what's going on in this app. So with Apple Pay or something like that, or with Samsung Pay, they're doing all of the application side for you. They're building the UI, they're building the payment credential part, they're doing the terminal communication, where in this case and in this app, we're doing all of that ourselves. So we're going to be going into the terminal communication, how to do a user experience, and then basically how you can manage users. So the heart of a Android HC application is a host APDU service. APDU means Application Protocol Data Unit, but it's generally in hex that you send back and forth as a byte array to the terminal. So you must extend Android's host APDU service, and then the purpose of it is to respond to terminal commands and send things back. And it's run when your application is triggered. So like you'll register in the system that I'm valid for Visa, or for MasterCard, or for whatever. And in this case, I'm talking just about payments, but there's another category called Other where you could do a transit app or loyalty app or something of that respect. So just want to show a little code sample of what this is. So as we talked about, it's only in Android 4.4 and higher, so I have a little target API in here so I get compiler errors otherwise. As I said, also it extends host APDU service. And this here is the heart of a contactless app. So this process command APDU is invoked every single time the terminal gives you a command. And in the flow I'll show you later on, it's actually invoked 4 times. So it passes in a command APDU, you do whatever you do to it, and then you pass back a byte array, which is the response. So finally, when that communication is done, the terminal will finally say, hey, I'm done. So this onDeactivated method will be called, and it usually says that the link was lost between the NFC reader. So you have to register this service in your Android manifest file so that you can be a payment application. So in here we have to specify our actual class name that we want to use, and that it's exported so it's available to the system, and that we need to bind to the NFC service. We also do an intent filter so that we're saying that we are a host card emulation application. And then finally, this metadata portion, you have to specify an external XML file that we'll go through, which pretty much goes through the entire configuration, like I mentioned, like what sort of platforms you support and so forth. So let's look at that. So this is the host APDU configuration file. First thing is going to be your banner, which I'll show you in a minute, like the Android settings. You can say, okay, there's Google Wallet, there's HANDSTAND Pay, there's an image that shows up there. So this is the drawable resource in Android that you're going to use. Then there's the description, which when it comes up and says, do you want to use HANDSTAND Pay instead of Google Wallet? That's the description that's shown there in the Android system. Required device unlock. So this is whether or not the device, so let's say your device comes up after you tap on a terminal, but it has like the swipe screen, right? It basically is saying, do you require the device to be unlocked before your service can be launched from a payment terminal? So in this case, I wanted it to be false, so it would just like launch my app. But it depends on what you wanted to do and the security requirements you had. Going down, like I talked about, there's payment applications in Android, and then there's other. They kind of left other kind of open-ended, but as far as payment goes, there are settings in the Android settings that we'll go through that actually allow you to pick your default payment application. In order to be a payment application, there's this lovely long AID, application identifier, that is for PPSE, which is Proximity Payment System Environment. And if you register for this, then it knows that you are a payment application. So this is the first command that gets sent. It says, hey, are you PPSE? And then you can say back, yes, I am, and then it goes from there. So we'll talk through that command flow. And then finally, with this kind of hacked version, this is the least secure payment application you'll ever use, but it's pretty much just sending the data that's on this card. However, yeah, it's Visa only, it only works in this case, and it's kind of just a legacy thing that's around and still supported. So the default settings, like I showed, this is where your drawable resource would come up. There's a little video here. Scroll down to your tap and pay settings, and this is on Lollipop. And you have the ability to toggle back and forth between Google Wallet and HANDSTAND Pay. Next thing would be the default payment application. So when your application launches, if Google Wallet is the default and you tapped on the terminal, Google Wallet would pop up, and then the payment's taken by there. So in this case, you can request to the system that you want to be the default app. Instead of taking them to the settings menu, you're going to ask here. So in this case, I programmatically ask for it, and then you come up with this preference. And just like I said earlier, HANDSTAND Pay is that description in the XML file. So to ask for a default payment app, so this is basically saying, am I the default payment app? And if not, let's prompt the user so that they can be the default. So I'm going to grab the NFC adapter using that context I have, grab card emulation services, and then I construct a component name, which is pretty much just saying this is my APDU service that I want to use to make payments. And so what we're going to do here is say, is my APDU service the default for the payment category? It comes back with a Boolean. And in this case, if it's not, I go ahead and pop up that dialog. So the dialog would then basically be sending an intent to Android saying I want to change the default for payments to my application. Lollipop kind of came out, and well, of course it came out. But in there, they have a new feature, which is this little toggle on the bottom you'll see kind of sliding back and forth. This is favorite foreground application, and it tries to deal with the fact that you're in HANDSTAND Pay and you're tapping on the terminal and you don't want to jump over to another app, even if you're not the default and the user doesn't want that. So if you say favorite foreground, it'll actually use your application, but there's a few things that you have to do. So you actually have to register and kind of like butt out everybody else in the system and say that, no, I'm actually the app running, I want to be the one used for payments. So in the on resume and on pause method here, I'm having a set as a preferred service and then the unset. And so the code that's actually running those two methods only work on Lollipop. And what I'm doing here is I'm just asking card emulation, do they favor foreground? Foreground overrides. And if they do, then in the case where I'm actually setting as a preferred, I'll go ahead and send in my component name again, which is my APDU service, and say, I want to be the preferred service, and on the on pause method, I'll go ahead and set unpreferred because I'm no longer on the screen. So that's a cool way that you can kind of butt in and be the default payment app. Okay, so how this app actually works, the communication between the service and our actual like UI code, is we have our host APDU service that I've kind of talked about a lot, but then we also have the UI, which has my cool little handstand guy. And first thing you do is when you tap on the terminal, the service gets activated. And what I do is actually start the activity in the background. So I start a new thread, and in that thread I send out an Android intent on the application contact saying to start my app up. And the reason why you have to do it on a background thread is because the APDU service that's actually getting the command and then sending back the command is like, it's single threaded. So it's one thing. So I have to basically start a new thread in the background to launch my activity. Otherwise it causes some issues. So that goes ahead and happens. And then after I'm finished processing the commands, I'm sending a broadcast intent through the local broadcast receiver, which is kind of like this general way that you can send messages between services and your activities. And so I'm just sending a message called payment sent, which is a static string I have. So this is the code that's starting activity in the background. As soon as I receive a command, I'm implementing a new runnable. And then inside of here, I'm saying, hey, just go start pay activity. And that makes sure that the UI will actually be showing when the payment's sent, and I can show the little cool animation. And then the ability to send that local broadcast, this is kind of like that piece in the middle that connects the two. I'm going to grab an instance of the local broadcast manager from the context, and then, well, using the context, and then I'm going to send that broadcast out saying the payment was sent. Also, on your pay activity, you need to be able to receive that. So I have a filter there. And so the activity already got started from that first command where it was in the background thread. It had the intent at the start of the activity. But this here is now on the on resume method, so when the activity is actually up, it's going to be registering for the local broadcast receiver, and if it gets the payment sent, then it's going to go ahead and do this animation. Let's see here. So let's talk about actually what's happening when you tap on the terminal. First thing, your phone's, so the terminal's sitting there just waiting. It's going to wait forever if nobody comes along. It'll be a very, very sad terminal. But if your application comes along, it'll finally recognize that something is within range. So it's going to say, hey, are you a payment application? And so the first thing is select PPSC. So that's Proximity Payment System Environment. So it's going to ask if you are. And this is the command that's sent over in hex. Pretty much we're going to write back and say this first red number is the PPSC, the same as you see above. And then below, I'm saying, yes, I support proximity payments, but I only support Visa. So next command, the terminal comes back, it's like, all right, great. You said you want to use Visa. Hey, do you want to use Visa? And then, of course we do. We just said we did. But I want to use specifically, you can see the A number is the same above and below, but I want to specifically use Visa MST, which is kind of this deprecated MAGSTRIPE way of sending data. Next thing is get processing options. Again, we're just kind of reiterating the fact we're Visa MSD. And then now the read record command is actually where payment information is sent. This is going to be sending the MAGSTRIPE information. I'll show you how to get it real quick. And if you look at the first highlighted red number, that is actually the PAN number, which is a credit card number. So if you look, Visa cards usually start with a 4, but there's 16 digits there. And then at the end here, you'll see 2406, which is actually backwards. So it's June of 2024. So all that information is being sent to the terminal. And in this Visa MSD format, it's the same as if I swipe my card, right? So if somebody gets this information, you guys can replay it, and that's why it's a prepaid card, and I'm not showing you any real data that's valuable. But I want to talk through some other security later on with keys and tokenization. And what happens is, in this case, in some of these extra data fields, they actually put in cryptograms, which when they end up getting to payment processors like Visa or MasterCard, they have to be decrypted and then make sure they match up with everything that they have on file. So even with just the token number and the expiration, you won't get too far in cloud-based HCE payments. All right, so I want to show you real quick how we send that information. Switch over to awesome open office. Thank you for being free. All right, so, oops. Just want to show you guys, not that. All right, so I have my little MAGSTRIPE terminal here. You see these in the store all the time. But all I'm going to do is basically swipe my card through it. So let's go over to the text editor. The way this works is it's actually registered as a keyboard on Mac OS. So I'm just going to swipe it through, and this is all the data that we're getting out of it. So this data here is, the first line is called track 1 data, and usually that doesn't contain much payment information that's useful. It's like your name and some other discretionary data. But at the bottom you'll see this area here, 49, that's your actual plastic number. And then as we saw before, there is your year and expiration. So kind of breaking that down on the slide a little bit clearer. I highlighted the numbers, but yeah, you have there in the bottom your actual card number and then all the other information. So I think I'm going to show it to you next. Let's see. Oh, here it is. Yeah, so I have an activity where if you click on that little icon in the middle where the card is, it opens up the set MAGSTRIPE data. So what you can do is if you get this, and if anybody really wants to, you can use my reader today and get your data off of your card. Don't let me do it, obviously, because that's a bad idea. But if you go ahead and do that, then you can paste it into this app, and you can try out your card. So I've done it with one of my Visa cards. The other one I tried, they suspected fraud. So you can talk to me about which one you're going to try to use, but depending on whoever the card issuer is, because if it's coming over a contactless terminal and it's not a contactless terminal, they might flag it as fraud. Yeah. All right, so yeah, once again, a warning, this has absolutely no security. The first 3 commands are pretty much hard-coded, but the last one, we're sending exactly what's on the plastic. So, yeah, All right, so let's talk about security and what we can do. So on-device security, obviously with any application, you have like a username and password you can use. In this case, because you're just making payments on the phone, you can use something like Device Administrator, which is used by like email applications and a lot of like secure things that are highly sensitive. The thing I'm really excited about is the Android M fingerprint sensor. And what's special about that is you can at any point in time prompt the user to say, enter your fingerprint or enter your password. This is really cool because currently you can with Device Administrator, you can find out if they have unlocked the phone or done anything with that, but you can't programmatically ask for it. So there's that, and then there's also another command in Android M, I guess I can call it Marshmallow now, which is confirm credential. And what that does is allow you to ensure that the phone has actually been unlocked in the last, let's say, 5 minutes or 10 minutes. So if you're worried about it sitting out somewhere, and they have a 60-minute timeout, then that's fine. So that's the on-device security. Let's talk about cloud-based security and how it works. So there's like 4 main parts. One part is tokenization, and I'll go into detail of like 3 different types of tokenization there are, but it's essentially taking the plastic number you have on the card and not using that. It's using an alias that is generated to actually make the payment. So yeah, we'll go through that. Keys. So these are things that are using cloud-based payments that are helped. The keys come down from whoever your tokenization provider is, and they're using combination with the token to generate the cryptogram and send over. So the keys are kind of like the magic that makes it all work and makes it secure. Device fingerprinting. So every time you're making a request to get new tokens, you can send information about the phone that makes sure it is actually the phone that requested the tokens in the first place. So device fingerprinting can make sure that you're not just like sending a command over the command line and trying to get a curl request. Like this actually has to have this device information. Now, granted, you could get that information, but it adds another layer of security. And finally, depending on your implementation, transaction risk analysis. So maybe if you aren't where your transaction's happening because it's on your phone, then you could use that as a piece to authorize or decline someone. So now I'm going to talk about 3 different types of tokenization. One is static tokenization, and this is where you have the actual card, you tokenize it, and you get the alias. So this is the one you're actually using if you make a payment. However, it's going to charge back to your original card. Next one is dynamic tokenization, and this one is awesome, although it's really basically expensive to do. So every single time you're making a purchase, you're generating a new card. And so I've had friends that have done this that have traveled internationally and didn't want to give their credit cards to people they didn't trust. So this is a good way because it's only valid for that one-time use, and then that's no longer valid. So. And then what's usually done with cloud-based payments is the SEM-DYNAMIC tokenization, where you get the one alias, but then the thing that makes it special is those keys I was talking about. And so the keys are given to you by the cloud-based server, and then you're using those to generate the cryptograms for the payment. So essentially, like the server always knows the master copy that you got last, and so they're only valid for a certain amount of time, so you're just going to rotate them out. And that way, on the device at any time, you only have a very limited amount of payments that you can make, and it has to be in sync with the server, right? So it provides it provides security there because it's only valid for a finite amount of transactions. And then finally, kind of putting everything together, how a contactless transaction works. So you have your phone, inside of there you've downloaded your token and then some keys that are in sync with the server. With those, you use crazy algorithms to make a cryptogram, and then that's went ahead and sent with the PAN data, or the token information, to the terminal, and that's that. So some tokenization providers, obviously most of these require like partnerships and you need to be a bank, but the one that is not is SimplyTap, and I want to give them a big shout out. They're based in Austin, and they've been really helpful. So the logic I got for sending a Visa card payment is actually from one of their GitHub projects, so it's referenced in mine. But I used their logic and kind of built a whole custom UI on it and the way that the app interacts. But they're really cool. They have an open SDK for actually the mobile app as well as issuers. So that's really cool. And then so what can you do now? You can go down to Dwayne Reed or somewhere else and you can get a prepaid Visa card so that you don't get yours flagged for fraud or something like that. You can grab one of these, check out or clone HANDSTAND Pay from GitHub and then go ahead and put your card in. And then if you want to go further than that and really check out more about mobile payments, go ahead and check out SimplyTap. They have an open SDK, you just sign up, you hit agree, and I've never found anyone else that has that amount of openness, so I really like them. They actually helped to contribute to Android's 4.4 spec for HCE, so they're one of the contributors. Questions, and then of course, like everybody, we're hiring, specifically our team in DC, 2 people, so if this is interesting, talk to me afterwards, but yeah, questions?
So it seems like you're basically downgrading from like a chip-based tap into just doing a MAGSTRIPE with the app.
I am in my implementation, yes.
Right.
So and the reason.
Is it up to the terminal to decide whether that's okay? It seems like you were showing the protocol. The terminal just okay. I'll use Visa MAGSTRIPE.
Right, and so that's something that's now deprecated. Like it's going to be out there because but as they go forward, they have fixed that. And they no longer in their new protocols accept that. So this is just something that, I guess the first iteration that came around, that's what was there, and so that's kind of the hack that SimplyTap had put together to make this work. But yeah, this is not the way it typically would work.
You tried it at 4 or 5 different places and they all accept it.
Right, because it's going to be supported for a long time, so it's just kind of one of those things.
Well, because the terminals during the transition time, will do both the
Correct.
contactless and
Yeah. I don't know any dates about deprecation or anything like that, but yeah, it's identified as not a secure way, so I think everybody that's implementing it is not going to do it in that way. It just happens to still be around. Any other questions? Comments? Dancing? All right. Thank you. Oh, sorry, one more. Did you have one?
I was going to ask, you mentioned at the beginning there's a secure element.
Yeah.
There's the software. Is there a way to still use the secure element? Like what's happening with secure?
Right, so you have to, the hardware manufacturer is the one that has basically the keys, or the keys of the kingdom to actually access the secure element. And so, unless you are the actual hardware manufacturer, you don't have those keys, you have to have a partnership with them. So, it's proprietary, essentially. Yeah. All right, thank you very much, everyone. Appreciate it.